So on page 155, we're going to start learning about exponential growth and decay, and it highlighted some important information. I'm going to continue to highlight. Up top it says this is like the main parent function, where b is greater than 1. It's the family of exponential functions. X is a variable in the exponent, and then we have two equations here that look very similar. The difference is in them is that this b right here, this is b, which is our base. This base is between 0 and 1, which means the graph is going to decrease. So I start with 100. This is like your A right here, or your initial amount. So I start with 100 of something, and every time x goes by, whatever x is, I'm going to multiply or halve. I'm going to multiply 100 by half or halve it. So I start at 100 down here, and then I go to 50, and then the 25, and then 12.5, and so on. This graph right here is going to be exponential growth because I start with 1 of something, but this time my base right here is greater than 1, which means I'm actually going to grow. So I start at 1, and then 2, and then 4, and so on, and I'm going to double it every time, making this bottom growth graph. And we use this a lot in real life when we study populations, bacteria, radioactive materials, temperatures, and whatnot. So on page 156, there's some examples. These are the basic functions for growth and decay, and your variables are outlined right here. And then it says exponential growth and decay are mathematical changes. The rate of change continues to either increase or decrease. It's not a constant rate of change, so it's not a line. In exponential growth, the rate of change increases over time. The rate of growth becomes faster as time passes. So the longer that goes on, the bigger the growth is. And exponential decay, the rate of change decreases over time, and the same idea, the longer that goes by, the more it decreases. So then I'm going to use this model right here, and this is kind of going to be our key function, where a is our initial amount and b is our base, and we're going to look at these two functions. So this is my a and this is my b. So a right here is 3 over 2, or 1.5, and my base is 5. And this one, a is 2 and my base is 1/3. And then it says describe the b value in each equation. So in this one, 5 is greater than 1, so we know that this is going to be growth. And right here, 1/3 is less than 1, but bigger than 0. So this one's going to be decay. And then it says that you can use a calculator to graph the following, but we're going to graph the following. And so we can use our calculator, but I'm just going to start out and point out some things. There's no plus or minus over here, which means both times on both graphs I'm going to have an asymptote at y equals 0. And that's because on both graphs at the end of it, right here, I have like a plus 0. And this plus thing at the end is always going to be my horizontal asymptote. This one right here is going to start at my initial amount. Like if I plug in 0 for x, 5 to the 0th power is 1. 1 times 3 over 2 is just 3 over 2. So this a value is always your y-intercept. So 1.5. And then I'm going to use my calculator. And you can do math in your head or you can use your calculator. But all I'm going to do is do 1.5 times 5. 7.5. So that means at 1, I'm way up here at like 7.5. And if you wanted to find another value, you can plug in -1. So you have 3 over 2 times 5 to the -1, which is like 3 over 2 times 1 over 5. If it's a negative exponent up top, we send it down to the bottom, and then we just multiply straight across. So now I have 3 over 10. So at -1, I'm at 3/10, like that. And so now I have enough points that I can draw my little graph. And so if I do the next one, my initial value is going to be 2. And then if I plug in 1 here, I'm going to get 1/3 times 2, which is 2/3. So like right there. And same idea, I could plug in -1. So I could do 2 times 1/3 to the -1, which means I'm going to flip this fraction over which is going to get me 6. So at -1, I'm all the way up here at 6. And this one, like we said, is going to be a decay graph. Okay, so what you're going to do is you're going to stop the video, and you and your friends are going to try to fill out this table and describe what happens when all of these algebraic changes happen. You're going to write down in words the effect on the graph, and you're going to go back to Edmodo and check the next video to see if you were right.